Hello and welcome to this lecture on integral calculus. Today we are going to see about evaluation of double integral by converting a Cartesian coordinate to polar coordinates. Let's start with the procedure. I have given a 5-step. First we have to sketch the given region by using the given limits. Then we have to change each of the Cartesian variable to a polar form. X can be written as r cos theta, y can be written as r sin theta, and we may change dx dy in term of r dr d theta. On third step, we have to make a substitution in the given function for the variable x and y as in the polar form. Then in the polar form, the variables are considered as theta and r, where theta varies from 0 to 90 degree and r varies from the inner radius to the outer boundary in the region. So after finding this, we have to make a substitution of limits and the converted function. Then at last you have to make a evaluation. That's all. I hope you understand. Now we move for the problem. So simply they have given a double integral. We have to evaluate this by converting this Cartesian coordinates to a polar coordinate. Okay, so first we want to take the limits. So if you see, x varies from y to a. So if I take the limits x equal to y and x equal to a and y equal to 0 and y equal to a, these are the limits. With this we want to draw a graph. So you just simply I may draw a simple graph. This is our x-axis and this will be a y-axis. And first thing, x equal to y. So I may take x equal to, this will be the graph for x equal to y. And now we have to go for x equal to a because x varies from y to a. So I may take the value a here. So this will be the value at somewhere a. So here x equal to a, at this point here it will be of a comma a. So clearly see, x varies from y to a. So x varies from y to a. This is the region for these two equations. Next we want to go for y equal to 0. Y equal to 0. Y equal to 0, that represents the x-axis. It represents the x-axis. Y equal to 0 and y equal to a. So I may take, so clearly it is known that a comma a. So this graph will be like this. So now you just see here, y varies from 0 to a. So here it is 0. So the region will be like this. 0 to a. I may draw some other lines. So if you see the overlapped area, you see the overlapping area, you will find this will be the common region. This will be the common region. Since I have given a clear version, here this will be y equal to 0, here it will be x equal to a, and this will be x equal to y. So this will be a common region. So with this, we want to find the new limits. Of course, we want to convert the variable x in the form of polar. So we know that we want to convert x into r cos theta, y equal to r sin theta, and we know that dx dy will be r dr d theta. So first we make a conversion. So here x square, x will be r cos theta, then x square will be r square cos square theta. So then we need x square root of x square plus y square. So here it will be r square cos square theta plus r square sin square theta. It becomes r will be a common thing. So I may take r and cos theta plus sin theta sin square theta. Here it is cos square theta plus sin square theta. It become 1. So simply square root of r square, it will be r. So the denominator is simply r. So finally the r get cancelled, we get r cos square theta. So with this we get a function r cos square theta. So instead of this I am making a substitution as r cos square theta. So we know that dx dy will be r dr d theta. So now you just see here, for the variable y the limits are 0 to a, and variable x it lies from y to a. So how do we get the new limits for theta and r? Let's start with the graph again. So what I told you that theta will lie between 0 to 90 degree. So clearly we know that this is the common region. This is the common region. So we want to find the angle as theta. So it starts with 0. So definitely the lower limit of theta will be 0 degree. And up to this we want to find how much the angle it makes. So here we know that according to the Cartesian coordinate, the equation will be of x equal to y. If I take the value x equal to y, we know that x can be written as r cos theta, y can be written as r sin theta. So r gets cancelled, then cos theta will be equal to sin theta. So for which value of theta both are getting equal, simply it will be of pi by 4, f 45 degree. So here the upper limit of theta will be pi by 4. So now we find the limits of theta. Next we have to go for the r limits. So I have told you that r will be starts with the inner radius to the outer region. R starts from the inner radius to the outer region. So this will be the variation of r. So clearly the lower limit of r will be 0 again, because it becomes 0 comma 0, and the outer region here it joins with the graph x equal to a. So with the help of this x equal to a, we want to find the new limit, that means upper limit of r. We know that x can be written as r cos theta equal to a, then r can be written as a by cos theta. So therefore the upper limit of r will be a cos theta, a by cos theta. So this is the limit of r, and this is the limit of theta. So we are taking the limits. R is vary from 0 to a cos theta, and theta will be 0 to pi by 4. And now we are multiplying the value r square cos square theta dr d theta. Then we want to evaluate this double integral. So next, this can be written like this. because now we are going to evaluate this part with respect to r. So with respect to r, the theta terms will be a constant, so I may keep outside the integral value, so I may evaluate this alone. So here I am taking the inner integral r square. If I integrate r square with r now, it will be r cube by 3. Then if I substitute the limits, and here instead of r cube 1 by 3 will be a constant, and r cube, if I substitute the upper limit, it will be of a cube by cos cube theta. So now what I have did, I have evaluated this part alone. Then I want to make a substitution of this again to this equation. So I'm making a substitution here. Instead of this, I'm making a substitution, so I get that a cube 3 cos square cos cube theta d theta, and cos square cos cube, it gets cancelled. Finally I'm getting that a cube by 3 1 by cos theta d theta. So since we know that 1 by cos theta can be written as secant theta. Okay, so now we want to integrate the secant theta. Since we know that integral of secant theta d theta can be written as log of modulus secant theta plus tan theta plus c. So we can use this formula. On the next slide, the secant theta can be written like this. Then we can apply the limits. So the limit varies from 0 to pi by 4. So a cube by 3, it remains constant, so I am keeping outside that, and I am applying the limits secant pi by 4 plus tan pi by 4. Then the lower limit will be 0. So we know that secant 45 degree will be root 2. Secant tan 45 degree, it will be 1. So here it is 1, and secant 0 will be 1, tan 0 will be 0. So I am getting this form. And now we already know that log 1 becomes 0. So therefore the remaining term will be a cube by 3 log root 2 plus 1. So finally we get the answer. So on the next, I am giving an exercise, the same similar problem. We want to change the Cartesian coordinates to a polar coordinates, and here we want to substitute the value x equal to r cos theta and y equal to r sin theta, and dy in maybe dx or dy in r dr d theta. By using this substitution, you can evaluate this. You just follow those steps, and finally you will get the answer 4 by 3.